There's no, okay. So we can start. So welcome to this Java 7. My name is David Delabassee. You can find me on Twitter using that Twitter handle. So I work for Oracle in the Cloud Application Foundation team. So in our team, we basically manage Java E, the platform, but also GlassFish and WebLogic. I work for Oracle, so I have to show you this slide. But since we're getting towards the end of the conference, I guess you have already seen it, so you had a chance to read it before. So the agenda for today, I will give you an overview of some of the important new features of Java 7. We just have 1 hour, so I can cover all the features, but obviously I will cover the big ticket features. Now regarding, I will also spend a bit of time on smaller features, and clearly what is important for me might not be important for you. So the idea of this talk is really to give you an overview of the Java 7 platform, give you some flavor of the new features, how to use them, and so on. Just by show of hands, who is already using Java 7 today? Yeah, so like 10%. Java 6, I guess most of you. Okay, majority. Are there still people on Java 5? Okay, quite a few. G2E 1.4? 1.3? Okay. Nobody, that's good. Okay. So, we are now at Java 7. Java 6 was launched in December 2009 in DevOps. So, 4 years ago, in fact, in the same place, we have launched Java 6. In June of this year, the specification of Java 7 was finalized, and it was released. So mid-June, we have done a big splash to launch Java 7. We have done that through an online show with online webcast, where most of the spec lead had section to explain the specification. We had online chat and so on. So we had something like 15,000 people attending that online event. So it was a huge success. In the Java 7 community, I'm in the expert group. We have nearly 200 experts working on the different specifications. Obviously, we have people from Oracles, but we also have a representative from Red Hat. So Red Hat was the spec lead of 2 specifications. IBM was spec lead for 1 specification. And in the expert group, we also had representatives from different companies, but also individual. So that means that as individual, you can also contribute to either specification or the umbrella Java specification. There are ways to contribute. Something else that we have done, and I think it was the first time, we have also launched a new program called Adopt-a-GSR, where the idea was to ask JUG to take specification, to play with the specification, take specification, write sample, take the implementation before it was finalized to try to really stress the implementation, to make sure that if there are issues, we can fix them before we ship it. We have done that, even in Belgium, so the BJUG played with the WebSocket implementation, and one of the results of that is that they have one of the applications they have developed as a sample is now part of the official Java 7 SDK. So that's another way you can contribute to Java E. Just a matrix, another matrix which is not on the slide. I think we have something like 15 books on Java 7 today. It's really the first time that the platform is launching. We have that many books available on the market. So it clearly shows that there is a huge momentum around Java 7. So what were the big themes of Java 7? HTML5, developer productivity, and meeting enterprise demand. So the first one I will cover, HTML5. So why Java E is embracing HTML5? Well, if you look today at the market, if you look at all the web UI technologies, basically all the proprietary ones such as Flash, Silverlight, all those technologies are disappearing in favor of HTML5. So clearly HTML5 is the way to go forward. So and that's why Java 7 is also embracing HTML5. So regarding that, we have added support for WebSocket to provide low latency, full duplex communications to your Java application. We have added JSON support to to provide an easy and lightweight data interchange capabilities to the platform. The REST API has also been greatly improved. I will show you some of those details later on. Servlet API has also been improved, for example, to add HTTP upgrade. So that's something that was required to add WebSocket support, and so on. So I will cover some of those details later on. Next, theme of Java 7, developer productivity. So that's something that was started with Java 5. So before Java 5, we have basically added technologies and capabilities to the platform. So the platform was complete, but it was, I would say, so complete that it was also sometimes complex to master. So that's why in Java 5 we have worked on, at that time we're calling that ease of development, trying to make the platform more simpler to develop with. How? For example, by using annotation. So we have Pojo, you use a few annotation to specify what you, the Java developer, expect from the Java container. And it's up to the container to provide you this behavior. So in Java 6, we have continued to work on that theme, and in Java 7, we also continue to work on that. So leveraging annotations so that you can use Pojo more across the platform, so that you don't have to write boilerplate code. And also, in Java 7, we are moving towards a more cohesive integrated platform. So the idea here is that in the past, we had the tendency, so each specification within the platform had the tendency to do all by themselves. Now we want to avoid that, meaning that if there is a technology which is available in the platform, it has to be leveraged by the other technologies across the platform. CDI is a good example of that. Expression language is also another good example. So there is no way to have two different expression language within the platform. Since we have one, all the technology within Java E should leverage that. And finally, meeting enterprise demand. So in Java 7, we have added on that front two new APIs. The batch API that allows you to write and run OLTP batch jobs on top of Java E. And the concurrency utilities for Java E, how to easily write concurrent code within Java E components. And finally, on that front, we have also worked to simplify the existing API. Two good examples is JMS, widely used in the enterprise. You will see that it has been greatly simplified. Another one, the REST API, we have also simplified part of that API. So this slide shows you the GSR that has been updated and added. So the fourth last one are basically new GSR that have been added to the Java EE platform. So WebSocket is new, GSR 356. JSON is new. Batch application led by IBM is new, and concurrency utilities is also new. All the others have been updated. Now, for some, the update is I would say, minor. So, for example, if you look at, let's pick GSF22, we have added a lot of small new features to the GSF API, but there is no huge improvements. It's really a more kind of minor improvements across the API. But for some other API, JAX-RS 2, for example, or GMS 2, well, more specifically GMS 2, it's really a huge revamp of the GMS specification. Maintenance release. So these are the GSR that went through the maintenance release following the GCP rules. So something which is important, maintenance release doesn't mean just cleaning of the specs. So for example, if you look at GTA 1.2, connector 1.2, there are new features that are important. But still, those updates are called maintenance release. So the first API I want to talk about is JSON-P, so JSON processing. So it's an API to parse and generate JSON. So it's not an API that can do binding, meaning binding from Java objects to JSON representation. Is not yet part of the API. That's something that should come later. So there are two variations within the API. There's a streaming API, and based on that, there is an object model API. So you should really compare those API towards their equivalent in the XML world. So we have stacks we have streaming API for JSON, and we have an object model API, which is more like a DOM API. So you would use the streaming API because it's highly efficient. It's low level, so that means that you have to handle the parsing logic by yourself. If you want something that is more easy to use, you can use the object model API, but it's not as efficient. So an example of the API, how it works. So if you want to parse, you just need a parser instance. There are factory methods to get those parsers. Then the parser, you just give it your JSON object, and the parser will basically feed you with events. We have an example there. So I have my parser. So I first get my parser, then I just iterate over the event I get from my parser. At the bottom of the slide, you see the different type of event you can get. There's not a lot of events. I think there is less than 10 events. And yes, we should have them here. So this is a very basic JSON object. It's a user object with a JSON array of phone number. So we can have a start object event, key name event, value string event, value number event, start array, end array, and an object. I think that's it. So this code shows basically you how to generate the JSON representation that you have on the right side. So it's the same object. So if you want to generate that object, you just need to have an instance of a JSON generator that you get through a factory class. And then you just describe your object. So something that I should mention is that Java is also evolving toward those builder patterns API. So you invoke a method on a method. So it's very fluent. So you will see that several APIs are using that patterns. So you just describe your object. So write start object, then you describe the first key value pair that you have. So the first name key value pair, last name key value pair, and so on. Then you have an array of phone numbers, so you invoke the write start array. It's a phones array, and you describe the two objects you have in there. Finally, you invoke the write end method 2 times. The first one to close the array, second times to close the object itself, and you are done. The object model API is also very easy to use. So you have a few objects, a JSON object, a JSON array, you have a builder, you have a reader and a writer, and that's about it. So in this case, we want to create the JSON object of that same JSON representation we have on the right side. So we invoked the JSON create builder method, and we just described again our JSON object. So we had a key value pair, which is first name John. We had another key value pair, last name Smith, and so on. So, we also had the JSON array. So we had phone, the object phone, which happens to be an array, and then we describe that array. And finally, once we are done, we invoke the build method to actually build the representation of that JSON object. So you see that the API is very and simple to use. Another API which is important when it comes to HTML5 is GSR 356, Java API for WebSocket. So WebSocket are basically, well, what is WebSocket? It's a bidirectional full duplex transport protocol. The nice thing about WebSocket, it's very, I would say, web-friendly. So the WebSocket handshake is done over HTTP. So whenever a client wants to do WebSocket connection, it issues an HTTP request using the HTTP upgrade, HTTP 1.1 upgrade mechanism. The server sends back an HTTP acknowledgement saying that, okay, I will upgrade this HTTP connection to a TCP-based WebSocket connection. So WebSocket is a standard defined by the IETF, and it's also part of HTML5. So if you have any HTML5 compliant browser, it has WebSocket support, and it has by default a JavaScript API that you can use for WebSocket communication. To give you an idea, even the BlackBerry browser have WebSocket support. So it's really available across all browsers. So this API allows you to do WebSocket. It defines two sides of the communication, in fact. So it's a Java API, obviously, but there is a Java client API and a Java backend API. Obviously, you can use the Java backend API against, for example, the JavaScript HTML5 WebSocket API. There are two ways to use the API, an annotation-based approach and a more traditional programmatic approach. On the backend side, so on the Java side, let's say that you are using the annotation approach. So you will annotate your POJO, and this will be turned into a WebSocket server endpoint. So the only thing you have to do then is to deploy it as a WAR. So it will deploy within your web container, and the web container will turn it and expose it as a WebSocket endpoint. So this is an example. So, no, sorry, this is not an example yet. A few notions. The WebSocket API is very simple. So we have the notion of endpoint. So an endpoint is basically one side of the connection. So we have a local endpoint and we have a remote endpoint. So if you are on the server, the remote endpoint is the client. We have the notion of session. Session basically represents the communication, the active conversation between two endpoints. And then we have events that will be generated. And what you will have to do, you will have to react on the events that are generated on the session. For that, we can use message handler to do that. So we have a few class, endpoint class, the message handler, that we will attach to react on a WebSocket event, session class, and remote endpoint. So this is the example I was referring. So this is a client side. So this is a client endpoint. So you see that we are using the programmatic approach. It extends the endpoint class. So that's the first thing you have to do. Then we implement the onOpen method. So that method will be invoked whenever there is a new session. So whenever there is a new session, that method will be invoked. So what we do in that case, we attach a message handler. So we take the session object. So again, the session object is the active conversation between my local endpoint and the remote endpoint, and we attach a message handler to that session that we define here. And that message handler will basically react whenever there is a new message coming in on that session. So whenever there is a new message coming in, that method will be invoked. And what we do there, nothing basically. We just print the payload which was sent by the remote endpoint. What we do next, we take the session object, we get the basic remote we get the remote endpoint. So that's basically the endpoint that is connected to on the other side, and we just in this case send some text. Hello. That's it. That's all it takes to write a WebSocket client. The same client, but using annotation. So it's a POJO. We don't extend any class. We don't implement any interface. So we are using the @client endpoint to specify that this should be turned into a client WebSocket endpoint. And we want to react on two events. The first one, using the annotation @onOpen. Whenever there is a new session, we take the remote endpoint and we send it some text. Hello. Sorry, that's whenever there is a new connection @onOpen. So whenever there is a new connection, we just take the remote endpoint and we send it a string, hello. OnMessage will be invoked whenever there is a new message coming in. Whenever there is a new message coming in, we just take the payload and we print it on the system output. So you see that we just saw the two approaches. You will agree that using annotation is a little bit less verbose, but it's up to you to decide. On the backend side, exactly the same approach. We can use programmatic or annotation-based approach. So in this case, we have a chat server, a very high-level chat server. So it's a POJO. We are using the add server endpoint to specify that this should be turned into a WebSocket endpoint. We are using the /chat that will be the URI where my endpoint will be exposed on the network. Then we are using the @onOpen annotation again to specify what should be done whenever there is a new session coming in. In this case, we just take the session object, so the conversation between the local endpoint and the new endpoint, and we add it to a collection. We continue. We annotate a method using the @onMessage. So whenever there is a new message coming in, what we do in this case, we take the payload. No, sorry. We take the collection of all the sessions that are connected to the endpoint. We iterate over that collection, and we just send the message that was sent to all of them. So we basically do a broadcast. And finally, @onClose will be invoked whenever there is a connection dropping. And what we do in that case, we just remove the session that has been just disconnected from our collection of sessions. So it's a very high-level chat application that will work against any WebSocket client API. So this is a very quick overview of the WebSocket API. You see that it's fairly easy to use. We see that we can send a text payload, but obviously we also have the ability to send a binary payload. We have the ability to attach encoders and decoders that can be used to convert Java object to a binary or text payload to be sent over WebSocket connection. All those methods are synchronous, but we also have asynchronous capability within the API, and so on. If you want to know more, I think there is a session on WebSocket right after this one in this same room. Another API which is highly important for HTML5 is JAX-RS. So in JAX-RS 2, we have added a lot of capabilities. The client API, filter, interceptors, asynchronous capabilities, hypermedia, validation, common configuration, and so on. One of the API I would like to talk about is the client API. So this is basically the JAX-RS 1.1 client API. If you wanted to connect to a backend RESTful web services in JAX-RS 1.1, you had to write that code. So you need a URL. Based on that, you do an HTTP URL connection, you configure the connection, you invoke the connection, you have an input stream that you pass to a buffer reader, you iterate over the buffer reader, and you whatever you have to do. So you see that it's a very low level. And the drawback of that is that it's so dirty that most of the JAX-RS implementation came with their own API to simplify that. It was odd because, I mean, on the back end, you had a nice front API to easily write JAX-RS web services, and on the client side, you had to write such a dirty code. So this is a new JAX-RS client API. It can be used, so it's a high-level API that can be used to access any kind of REST resources. JAX-RS resources, but any other REST services. It's obviously not tied to JAX-RS. So what you need to do, just get an instance of the client interface. You configure the client instance with a target. Then you create a request based on that target. You invoke the request, and you are done. So you see that it's a fairly elegant API. It really matches the way we program on the backend side. I mean, JAX-RS backend side services. So I think that this is more or less the most simple way to use the API, but the API is obviously more powerful than that. So we see another example. So in this case, in the target, we are using a template. So order ID, we are registering filters. So the template order ID in this case will be resolved, and we'll use 10 instead. We also have the ability to use query parameters and so on. In JAX-RS 2, we have also added asynchronous capability. So if you wanted to do an asynchronous client invocation, you just have to add invoke the async method, and it's all it takes to do that. In return, you get a future string object that you can use to later on see if your request was completed, if there has been an issue, or get the result of the request. Now, what you can also do optionally, it's shown on that slide, you can also define callbacks. Callbacks that will be invoked whenever the request is completed or whenever the request failed. Something else that was added in JAX-RS 2, beans validation. So we can add a validation constraint now on JAX-RS endpoints. So if you look at the example, in this case, we don't want the form parameter first name. We don't want a first name form parameters null. We don't want the last name, again, to be null. And finally, we validate the email form parameter using custom email validators. So those were some of the features that were added to JAX-RS 2, but there are a lot more, such as filter interceptors, hypermedia support, command validation, and so on. So moving on, manage bin alignment, so moving towards a more cohesive integrated model. So CDI is really becoming a core component model within Java EE. It's enabled by default. So if you have been using CDI in Java 6, well, if it didn't work, the first thing you had to do is check your bin XML. Bin XML was missing or something was wrong there. Now you don't. I mean, if you have, we have this notion of implicit bins. So any bins archive that has a scope will be considered as an implicit CDI bins, so you don't need any bin XML there. But obviously, you also have the ability to tag classes if you don't want them to be CDI enabled. For that, you will use the add veto annotation. There is an expanded use of CDI across the platform. A good example is the CDI interceptor. So we have transactional interceptors. We have method level validation interceptors. We have new CDI scope. We have the add transaction scope, which is used to attach CDI bins to an active GTA transaction. We have a new scope for GSF, the add float scope, and so on. So this is the transactional interceptor. So in the past, transactions were basically handled in the EGB container. So as a developer, you were kind of shielded from the low-level GTA API. And the idea with the transactional interceptor is to bring you the facility but outside of the EGB container. So meaning CDI managed bin can now have can declaratively control transaction boundaries. So this is available for CDI managed bin, servlet, JAX-RS endpoint, and so on. And if you look at the annotation, you will see that you can apply that interceptor. First of all, it's an interceptor. You can apply it at the method level or at the class level. That by default, the transaction type is required. And you also have the ability to customize the behavior. So which exception should be considered for rollback and which should be ignored. So you don't want them to trigger a rollback. So bins validation 1.1. So it's a minor update of bin validation. The big features in bin validation, it's method level validation. So we basically had that example in JAX-RS. It's how it's implemented. So now you have the ability to do validation on method parameters and on method returns types. So if you look at these place order methods, we do a validation on its parameters. So we don't want to have a product name null. We want to have a quantity that is maximum 10. We don't want the customer name to be null. And finally, the customer address should be validated using an address validator. What we are also doing in this case, we're also applying a validator on the return types. So the order that is returned by the placeOrder method will be validated using this valid order custom validation. And technically, behind the scenes, those validations are implemented using CDI interceptor. So that's a good example that the platform is really moving toward this integrated model. So BINS validation is using CDI. JAX-RS is using BINS validation. So we don't want now to have part of the specification that reinvent their own wheel by themselves. If there is a good technology, they have to use it. There is a new annotation regarding the interceptor, that's the add priority interceptors. That allows you to define the ordering in which the interceptor will be invoked. So basically what you do, so you use that interceptor to specify which interceptor you want to have, and you also add the add priority annotation to attach it priority. It's number based, and so what the specification also defines is range that should be used. There's nothing that force you to use those range, but obviously it's really a good practices and a good idea to stay within those range. So depending on whether you are providing a library or an application and so on. So the only thing that the specification, doesn't say is if you have two interceptors with the same priority, the order in which they will be invoked is not specified. So that's something that you have to keep in mind if you have such a case. Something else, so resource definition metadata. So that's not something which is new to Java 7. That was part of Java 6, I think. It was introduced in Java 6. In Java 6, we had this at data source definition that you can use to define and configure an object, in this case, a data source. So the idea is that you can use this annotation within your code instead of specifying that within an external deployment descriptor. And there are use cases where it makes sense to have to do that. So for example, it can in some cases facilitate the provisioning if you are in a cloud-based environment, those kind of things. You can also combine, the definition and the deployment descriptor. But that's not something that is new in Java 7. What is new in Java 7 is that we have added a new resource definition. There is a JMX connection factory definition, a GMS destination definition, a mail session definition, so this is for Java Mail, a connection factory definition. This one is for defining resource adapter. And finally, there is an administrative object definition. So now you have the ability to use those definitions to specify and configure those objects within your code directly, and you can inject them afterwards. Something else that has been added to Java 7, and again, this is something we are doing to try to simplify the platform. The specification defines default resources. So we have a default JDBC resources. We have a default GMS connection factory. And finally, we have default resources, so namely executor services for concurrency utilities. So the last one I will explain that later. So that means that now if you don't specify a data source in your code, by default, the application server will use the default one, which you don't have to configure. The application server provider needs to have it configured by default. So in some cases, you don't have to specify, for example, GMS connection factory. If you don't, you will get the default one. So it's really convention over configuration. But obviously, you have the ability to override those settings. simplification through pruning. So I told you that we have added a lot of stuff in Java EE. I mean, if you look at the G2E 1.4, it was big. We have continued Java E5, we have added new capabilities, Java E6, and so on. So we continue to have stuff, but we have never really removed anything from the platform. So what we did in Java E6, we have started what we call pruning. So pruning is basically a way to put some warning flags on some specifications that are not really useful anymore. So in Java E6, we have pruned a few specifications. So that basically means that in Java E6, they were marked as propose optional. So they were still there in Java E6, but we want to inform you that they might disappear over time. So in Java E6, they were propose optional. Now they are optional. I mean, Java E7, the specification doesn't mandate that you should implement those features. So if we look at the features that were marked as propose optional in Java E6, entity beans, so container managed entity beans, bean managed entity beans, EGBQL. But clearly, I don't think that anybody is still using those technologies today. JAX-RS, JAX-R, GSR88. So clearly, if you are still using those technologies today, it's really the time to look at them, because if you take a Java E application a Java E7 implementation, those features might not even be there. But we have started to warn you in 2009 with Java E6. And clearly, if those features are optional, there are clearly alternatives within the platform. So, something else, Java Message Services, JMS. Who is using JMS? So quite a few. So if you are using JMS today, you are on Java E5 or Java E6. That means that you are using JMS 1.1. JMS 1.1 was defined in 2001, I think, and we had a maintenance release in 2003. So that basically means that you are using today an API which is 10 years old. So that means several things. First, since it's widely used, that means that this API fulfills a need. I mean, if it would be useless, nobody would use it anymore. It also means that the API is quite okay. If the API would have been broken, again, nobody would use it anymore. But it also means that you are using an API that is 10 years old. So that means that this API has not been able to leverage any of the new capabilities that we had in the Java platform since 10 years. So by Java platform, I mean Java EC and Java EE. So that is really the focus of JMS2, trying to simplify and add the new features that we have in the platform to the JMS API. Now, since JMS is widely used, we don't want to break backward compatibility. So there are two API within JMS2. There is the classic API, which is the old JMS 1.1 that you are all using today. And we have the new simplified API. The idea is that using the new simplified API, you have to write less code, less boilerplate code, so that it's a lot simpler to use. The goal is really to focus on developer productivity, and you will see how it works. So simplification includes, we have a new JMS context interface. It's really the main interface you have to know. We can use CDI injection. We have the ability to use the new transaction scope. The JMS objects are now leveraging the auto-closable interface that was introduced in Java EC7, so you don't have to close those objects. They will be closed automatically by the platform. We are using runtime exception. In JMS 1.1, exceptions are checked, so you need to handle them. Now we have runtime exception. Method chaining on JMS producer. So again, this fluent builder pattern where you invoke a method on a method and so on. So the new simplified API, three interface, JMS context, JMS producer, and JMS consumer. So before showing you the JMS 2 API, I want to show you the existing 1.1 API. So this is all it takes to send a string using JMS. So if we look at the code, so we need a connection factory, we need a queue. Then from the connection factory, we get a connection. From that connection, we need a session. To get that session, we have to pass parameters, which in the case of Java EE are misleading, because they are basically, well, they are misleading, and the issue is that obviously if you don't pass them, you don't have the right signature, so that won't work. So you have to pass those misleading parameters, but you have the session. So from the session, you need a message producer. Now you want to send a string, but you have to convert that string into a text message type. And finally, you can actually send your text message. So that's basically the bold line where all the action happens. But still, you have to write all this code before. So a lot of boilerplate code, and we are not done because we also need to make sure that we close the connection, because a connection is an expensive object, so we need to make sure we close it. We also have to make sure that we handle all the exceptions, because the exceptions that are thrown are checked, so that's something we have to take care of. So basically, you see that to do something very basic, just send a string, you have to write a lot of boilerplate code. You have to create a lot of intermediate objects. You need to close them, and so on. So it works, but clearly they are, well, we can improve things. So this is how it works in a JMS 2, to send, again, the same string message. So I told you we have three objects, JMS context, JMS producer, and, JMS context, JMS producer, and JMS consumer. So the one you really need to keep in mind is JMS context. It's basically, it combines the functionality of two JMS 1.1 objects, a connection and a session. So if you have a JMS connection, you don't have to create a connection, you don't have to create a session. It's basically handled for you behind the scenes. Then once you have a JMS context, you can have a producer. So it's a lightweight replacement for the message producer we had in JMS 1.1. So if I need to send a string, what I need to do, so I still in my connection factory, I still in my queue. I just need a JMS context object. So for that, I invoked the create context method on the connection factory. Then once I have my context, I need a producer. So I invoked on my context the create producer, and finally I can send the actual text. So a few things to mention. So first, you see that we can send directly strings type. We don't have to convert that to anything. So we can directly send string over JMS. Again, you see these patterns where we have the context, we invoke the create producer on it, and we then invoke the send method. So it's very fluent. All the exceptions that might be thrown by this code are unchecked. So you don't necessarily have to handle them if you don't know how to handle them. Obviously, you need to know what is happening. So you see that if you compare that to the slide before, it's really a lot easier to, it's a code that is a lot easier to write and to understand. So meaning also that it will be easier to maintain. But we can go further than that. So we can inject the context. So if we inject the context, its life cycle will be managed by the container. So that's something that we won't have to do. So that's what I'm doing here. So I'm injecting the context, and I'm using the @JMS connection factory to specify which connection factory I need. And then the rest is the same code. So from the context, I need a message producer, and then I can invoke a send on that one. So the @JMS connection factory annotation is used to specify which connection factory to use. Meaning that, remember that I told you a few slides ago that we have default resources. So if we don't specify any GMS connection factory, we'll get the default one. So that's what we are doing here. So we just do an @inject GMS context. So we'll have a context that is using the default GMS connection factory. And then the rest of the code is the same. So you clearly see that in terms of productivity, there is a huge gap between GMS 1.1 and GMS 2. If you have GMS 1.1 code, you can use the classic API, but keep in mind that the GMS 2 API is a lot simpler to use and way more productive. So we have this GMS context object that handles the session and the connection for us. We have the GMS producer. We don't have to do payload conversion. We have the ability to inject objects, so we don't have to manage their life cycle. Now, exceptions are unchecked. Objects are using auto-closable interface, and so on. So there are a lot of things that make the GMS 2 API a lot simpler to use. So something else, a new API which has been added to Java EE 7 is the concurrency utilities for Java EE 1.0. That's a long name. I think it's GSR 236. So until now, if you wanted to have a concurrent behavior within your Java EE code, you had different ways to do that. You could use the @asynchronous annotation. Another example which was often used was using a pattern, and so where you fire a message on a GMS queue that is being picked up by a different MDB, and those MDB trigger jobs in parallel. So you had different approach. The only thing that you couldn't really do was to use the concurrent capabilities you have in Java EE. Why? Well, Java EE is basically a managed environment. So it's a managed environment that is providing you services, injection, transaction, security, and so on. So if your component, so your servlet or your EGB, was starting new thread, well, in some case it won't work at all. In some case it might work, but you can expect to have issue very quickly. Because basically those threads, so you have a managed code that is spanning new thread. So that means that the container has no visibility on the extra thread that you have created. So clearly, from a spec point of view, that was a big no-no to do that. That was unsecure, and clearly, if you were doing that, things could quickly go wrong. So what we are doing here with these GSR, so the concurrency utilities spec, we basically allows you to leverage the concurrent capability of Java EE within your Java EE code in a safe way. So if you have been using the Java EE concurrent util package, it's basically what we are bringing to Java EE. So you can now use, in a safe and secure way, the Java util concurrent package within your Java EE component, so servlet and so on. So there are 4 new objects: the managed executor services, the managed schedule executor services, the managed thread factory, and the context services. And again, if you are familiar with the concurrent util package of Java EE, in Java EE you have an executor services. On Java EE we have a managed executor services. So it's basically the equivalent, but it's managed by the application server. And we also have the ability to do context propagation, because if you span a new thread or a new task, it might be useful that this new task or thread has access to the Java EE context, for example, to know which user we are currently working with. So how it works, you see at the top of the slide, I have an account task that implements the callable interface, and I have one method, the call method, and that's where I have my business logic. So this is, I would say, pure concurrent util Java EE code. At the bottom of the slide, we are in a Java EE environment, so I can inject my executor services. So in this case, it's a managed executor services. And I will just submit to that executor services my task. And it will be up to the executor services to do all the dirty jobs of scheduling the task on the threads that are available, handling the synchronization, and so on. you get in return back a future object that you can use to query the status of the execution of the task or get the result and so on. So you see that if you know the concurrent util package of Java-EE, you have now the same capabilities within Java-EE. Something else, GSR 352, led by IBM, the batch application for the Java platform. So designed for non-interactive, bulk-oriented, long-running tasks, so basically batch jobs. So we have been using computers since decades to do batch jobs, but until now, if you wanted to do that in Java, you had to either buy a product or write something by yourself using maybe an open source framework such as Spring Batch. Now we have a standard way to do that within Java platform. And if you look at this specification, if you are using Spring Batch today, you will see that there is a lot of familiarities. I mean, Pivotal was involved in the specification. So a few concepts. We have a job. A job is made of steps. A job needs at least one step. A job without a step is useless. We have a job operator and a job repository. So job repository is basically metadata store. The specification doesn't say how it should be stored, but that's more an implementation concern. And we have a job operator, which allows you to control your job. So start a job, get metrics on the jobs, and so on. So it's really an API. Job steps, so that's basically what you will write as a Java developer. There are two kinds of steps, chunk steps and batch steps. Most of the time you will do chunk steps, because that's the one who works on data. So you basically read something, you do some processing on that data, and you write something out. But sometimes you also need to perform some specific task. So for that, you can use batchlet. So a typical batchlet example is at the end of a job, you need to take all the results, sign them, and put them in a data warehouse. That's a task. It's not really related to any data. So for that, you will use a batchlet. And obviously, you can mix and match. I mean, you can have chunked, and obviously you will have chunked, and you can have batchlet within the same jobs. So the API defined two things. Sorry, the specification defined two things. A DSL, which is called a GSL, so it's a job specification language. So it's an XML DSL that allows you to assemble together all the different steps. So really define the jobs, in fact. And then what you will do as a Java developer, you will have to implement the different steps using Java code and using the Java API. So this is an example of, in this case, that's item processor. So I need to implement the item processor class. So once I've done that, I can use the GSL, so the XML that I had just before, and I can reference that code from within my job. And what I will run at the end of the day is the job itself. You have the ability to add listener to intervene within the life cycle of the jobs and so on. So it's a very rich API. And if you want to know more, there is a session tomorrow on that API. GPA 2.1, a lot of small enhancements. The only one I will talk about is you have the ability to generate database artifact. Well, GPA has the ability to generate database artifact based on your entity. So this is useful, for example, for iterative development. So each time you deploy your application, your database is recreated and populated with new data. So it's time to wrap up. So Java E7, the big team, HTML5, developer productivity, and we continue to add new enterprise features. Batch, concurrency are a good example. There is way more than that. I've just barely scratched the surface. I haven't talked about EGB 3.2, Servlet 3.1, connector, and so on. It's a busy slide, but I just want to mention that we are trying to get as transparent as possible when we define the Java specification. And you see that there are clearly ways to be involved within the Java EE world. I mean, if you have contribution and if you have ID for Java EE 8, well, we would really want to hear from you. Call to action is to download the Java E7 SDK. It's released It's available since mid-June. So in there you have GlassFish 4, the Java EE 7 reference implementation. It's open source. And we also have the Java EE tutorial. So it's a 1,000-page PDF that you can use to learn the different technologies that are part of Java EE 7. Now, I have a few minutes left. I just want to mention something around GlassFish, because I guess some of you have heard that last week we have announced that we won't have a commercial release of GlassFish 4, but that has no impact around GlassFish, the open source edition. So GlassFish 4 open source edition is available. We plan to have next year an update of GlassFish 4 open source edition, and we also plan to have GlassFish 5 open source edition as the reference implementation for Java EE whenever Java EE will be ready. So if you heard rumors saying that GlassFish is dead, that's not true. It's just about the commercial edition. We won't have any commercial edition of GlassFish 4. But GlassFish as it is remain open source and remain open. So with that, the only thing I would like you to do is to download the Java EE 7 SDK and give it a try. You saw that there are a lot of enhancements within the Java EE platform, so that's something you should really consider moving forward. Thank you.